Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
In this example, given this configuration here, where we have a metal bar that slides along these two rails here, that completes a circuit where we generate our voltage for the circuit via motional EMF by moving the bar in a constant magnetic field. We want to determine how far we'll have to slide this bar in order to power a 60-watt light bulb for half a second. So our time interval here is half a second. Okay. So what we might want to determine first is, well, how fast are we going to have to be sliding it in this half second in order to generate 60 watts for our 60-watt light bulb? So if you recall, the power dissipation across a resistor is just going to be V squared over R, where in our case, our voltage is just the motional EMF we generate by moving the bar, so just E squared over R. Where our motional EMF, given that the velocity of the bar, the magnetic field, and the length of the bar are all perpendicular to each other, and the field is constant, is just going to be V times B times L. Velocity times the magnitude of the field times the length of the bar. So if we plug that into our equation for power, we're going to get that the power generation is V BL squared over R. And of course, the power we want to generate is just that for a 60-watt light bulb, which of course will need 60 watts of power. So let's see what our velocity is going to have to be for us to be able to generate 60 watts of power. That is 60 joules every second. So if we multiply both sides by R, we'll have 60R. Take the square root of both sides, and we'll have VBL equals the square root of 60R. And then divide both sides by BL. So we'll have the velocity needs to be the square root of 60R divided by BL. Okay. So now that we have an expression for the velocity that we'll need to move at, well, we know that velocity and distance and time are all related to each other, right? And we specifically are interested in how far we'll have to move the bar. So we know what velocity we'll be moving it at, right? It's whatever number this comes out to. And we know how much time. And if we know that velocity for a constant velocity is just delta x over delta t, right? Change in distance over a change in time, then our delta x is just going to be v times delta t. So delta x, by that logic, is just going to be delta t times the square root of 60r over BL. So if we plug in all those values, half a second for delta t, for our resistance, 240 ohms, B is 0.4 Teslas, and L is 0.6 meters, we will get that delta x is going to be 250 meters. And just in case you're curious, V was going to be 500 meters per second. So we'd be moving this bar at 500 meters per second for half a second just to power this light bulb for a half second. So Our little power generator here is unfortunately not that impressive, but we figured it out. So there you go. We'd have to move our bar 250 meters in order to generate enough wattage to support our light bulb.